FE Civil Exam Water Resources Hydraulic Jump Problem. Hi and welcome to your channel FE Civil Exam with Farhad. So in this example we want to review an example in hydraulic jump in terms of FE, and also it could be a question of P exam as well. So let's start our problem. So we want to calculate the discharge in terms of SI unit meter cube per seconds in a hydraulic jump, which the conjugated depths are provided, like the y1 is 0.5 meter and the other one is 1.5 meter after jump. The cross-sectional area before the jump is provided, which b is equal to 4 and y equal to half a meter. We want to calculate the discharge for this problem. So let's approach our problem. So first of all, if you go to any fluid mechanics, hydraulic engineering, and FE and PE guide, a reference book or guidelines, you can easily see an equation which refers to hydraulic jump that includes a relation which relates the conjugated depths to each other. So the alternate depths are related with to each other with this equation, and then you can easily see the fruit numbers appear in our equations. So the fruit numbers is nothing but the ratio of inertia forces to gravity forces, for example, and we've defined it for the cross-sectional area. So for example, for the first cross-sectional area before the jump, we call it Fr sub 1 is equal to V1 over square root of G times hydraulic depth, which is our Y1 here. And fruit number is nothing but the inertia forces to gravity forces, as you can easily see in the formula, and that's how we write it down. Because in the mentioned formula you can easily see we have like the fruit number appears in the square root, so we have to make our f fruit number in first cross-sectional area squared. So that gives us fr squared is v1 squared over g times y1 comes out of the in a square root. Mhm. So if we just jot down our equation again and replace what the numeric number what we have. So y2 is equal to, after the jump height, is equal to 1.5 meters, and then before the jump that's y1, which is a half a meter, then divided by 2 based off the formula, in parentheses minus 1 plus, just replace the fruit number by the this equation, and then replace g by 9.81 in SI unit times y1, which is 0.5 meters. Mhm. The only unknown in this equation is v1. Mhm. And if you solve the equation for v1, it just gives you v1 is equal to almost 5.5 meter per second. And as soon as we have our velocity in any of this cross section, we can easily calculate the discharge, which is area. For example, this is our A1 times V1, which is a this numeric number. And if you do the math, it just gives you Q is equal to 10.58. And that's choice D. Thank you. We'll solve more problems in fluid mechanics, hydraulic engineering, water resource section of FE and PE exam in this channel. Thank you.